Anyway, not sure what's going on with the slides, so we'll just go through this. Always a good time. As I said, it's about an hour drive from Mazatlan. In the diagram there, you can see that we're right along Highway 40D. Highway 40D actually crosses through the property. And along that route, there's also a high voltage power line and great existing infrastructure. The land package that we own, we've actually tripled in the last year, since January 2024, and sits roughly around 30,000 hectares currently. And we're applying really modern exploration techniques to basically expedite exploration from discovery. The first discovery on the property was about 6 years ago. And if you stop in at 5:30 p.m. today, my colleague Jesus Velador is giving a much more detailed exploration talk on the property. Okay. I wasn't finished the slide, that's okay. So, as I suggested, this project really has unrivaled infrastructure. We've got site access for 2 highways actually run through the property, and the process plan is planned to be about 1 kilometre off the highway, so getting infrastructure to the processing facility will be quite easy. We are an hour away from a deep water port in Mazatlan as we sit here today. We have 2 different power lines running through it at 400 kilovolts and 240 kilovolts. And seasonal rain collection allows us to get most of our water from basically dewatering of the mine rather than taking from local rivers or streams. And there's great local service providers all around Mazatlan and Durango, which sit either side of our property. Do you know what happened with the slide? Earlier this year, we released an updated mineral resource estimation. It included the first measured section of our resource. So as you can see, measured and indicated currently sits around 220 million ounces of silver equivalent, and inferred sits around 140 million ounces. The measured portion of that sits around 45 million ounces of measured resource. Through the last 3 years, we've systematically increased this resource, and we're embarking on a feasibility study this year that will only use the measured and indicated resource category shown here. We have 3 basically tiers of development that we're looking at. The first one in advancing development is we're on a fast track to production. So as I said, the first discovery was made approximately 6 years ago. And we're planning for first production in the second half of 2027. So around 8 years from discovery to production is a relatively rapid timeline in today's environment. We've got a very strong cash position at the moment. We've got around 90 million US that's going to help us develop. And what we're planning is that as the permitting gets more mature, we have our permit submitted. When that permit does get approved, we hope to go straight into construction. So that's part of trying to get to production as quickly as we can so that we can actually help put back into the local community. And de-risking, our conversion drilling has been very successful to date. If you go through the mineral resource estimate updates, we've been systematically increasing with infill, and the recent MRE is no different. The exploration upside, it says here we've explored around 30% of the known veins. Some of that is just putting a single drill hole in some known vein locations. However, the actual resource sits only on about 10% of the known veins. So there's a lot of area left to explore, and just over about a week and a half ago, we released some drills from a new zone, which is the Animus zone. And the highlighted drill was around 6 meters at 900 grams of silver equivalent. So there's still plenty of silver left on this property to find. And as I was saying, we're also looking to expand the drill package. And then the last tier of our development is actually responsible growth. So we want to make sure that we're always looking to invest locally. We're trying to use as much local content and local contractors as possible. And we're also looking at ways to basically give the community some better infrastructure as we develop as well, which we've got some initiatives with the Power Authority to try and get more reliable power into those local communities. This is our development timeline. So this goes from the PEA, which we actually finished in the second half of last year, which has the results that Jorge will be talking about later in this presentation. We did conversion drilling late last year and released a mineral update in January this year. And we commenced a test mine, which I've got a slide on in a little bit that'll go through what we're trying to achieve with the test mine and where we're heading. As I said, we have submitted our permit, so we did a lot of work with the permitting agencies and have submitted that in early February this year. And our feasibility study commenced in January this year with a target to finalise that in the second half of this year. So we're all moving towards that construction date, and the goal of that is to start construction on site and break ground in early next year, with first production aimed for 2027 half two. As I said, one of the pillars of our success is really going to be making sure that we are involved with the local community and doing our sustainability. So if anyone's interested, you can actually go onto our website and look at we've released 2 sustainability reports so far, and those cover things like, potential greenhouse emissions, water quality, local community, etc. We're also trying to involve as many local contractors as we can, so we have used like a Conso who has local contractors and everything else, and a lot of the sponsors of this conference actually have worked on our property. So now into the interesting stuff, the PEA results. So when we looked at the PEA, we were only looking at the inferred resource at the time, which ended up being about 179 million ounces of inferred into that mine plan, and it produced a total of about 10.6 years of mine life. The average ounces per year was around 15 million ounces of production per year, at a 3,300 tonne per day initial feed rate, with a ramp up to 4,000 tonnes per day in year 4. The NPV of the project was around 1.1 billion, so the NPV over capex ratio is around 5, which is sensational, and the IRR was around 85%. Some of the metrics here, like the all-in sustaining cost, are like the lowest quartile of the industry at $9. This is our production profile. So these are actually produced ounces. As you can see, we start off with the Kapala deposit and the highest production at around 20 million ounces for 2 years. And then as we go into the lower grade deposits such as Napoleon and La Luisa, we actually expand the mine to get more ounces per year, but we average out at around that 15 million ounces of total production per year, and for a total of 162 million ounces recovered. So that 179 million ounces of feed translated into 162 million ounces of recovery, which is, sitting around 89, 88%. And this is the site layout proposed from the PEA. I've heard the laser pointer doesn't work on this screen very well, but yeah, the processing facility is, as you can see, is right underneath the high voltage power line, so that will be great for accessing reliable power. We don't want to start up our processing on brown power, so this is crucial to us getting a smooth commissioning. Our tailings storage facility is located approximately 5 kilometres away via road, so the actual path comes down off the screen and then back up underneath Highway 40D. And the Kapala portal shown in the middle there is actually the site of the test mine. So that's actually where we're drilling our, we've got a box cut and a portal going in as we speak today. So this is our fully permitted test mine. We've started construction on this. The overall scope of this is twofold. One is to collect a 10,000 tonne bulk sample. That bulk sample will be used for a range of metallurgical tests, a range of sustainability tests in terms of like tailings, stability, waste, making sure there's no ag or pag, things like that. But the other key thing for us was actually, let's get underground and actually understand the geotechnical considerations that we're going to be working with. Because no matter how many drills you do as a geotechnical program, you never truly understand exactly what's going on until you get down there. And so that nearly 1,000 metres of basically ramp development will help us get a real understanding of how strong the rock is, how much support we need and to lower the risk of future development in terms of both productivity but also people safety, which is a big consideration for us. And this is just to summarise my section of the presentation, but these are the areas of enhancement going forward, which we've completed infill drilling, but we're always looking to complete more infill drilling and more exploration drilling to further increase our measured and indicated and also overall resources. We've undertaken a optimised metallurgy program, so that'll play into some of the things that Jorge is about to talk about, but that's nearly complete now and it's being a feed product into the feasibility study. Optimised mine design and scheduling. One of the things we learnt in the PEA is that there's a bunch of different ways you could approach our specific deposits and how they're laid out. So with more geotechnical data that we're currently receiving, we're actually looking to optimise that and minimise the basically waste development. And then, our feasibility study, as I said, is ongoing, and we're looking to expect to finish that in half 2 this year.
Okay. First of all, let's talk about the process design for the plant. As it stands right now, it's an underground operation, and it's going to be divided into phases. First phase will be a whole ore leach operation, and then when we get into year 4, it's going to expand into a float operation with a concentrate leach attached to it, and we'll see the reasons for it in a later slide. There's power line nearby, there's roads nearby. The tailings will be thickened, conventional thickened tailings going into a tailings dam. For water supply, we expect that most of the water comes from mine dewatering, but there will be some water extraction at the beginning of the project from wells and from a river nearby. And the weather here, it's arid, warm weather with annual 4-month rainy season. So right now, as it stands, this is the flow sheet that we came up with. The first stage will be comminution. It will be conventional 3-stage crushing with a ball mill, a closed circuit ball mill at the end. Then it will go into dynamic leaching, and then washing of the leach liquor through CCDs. The solution will go into a Merrill-Crowe plant, and the tailings will be detoxed to destroy the cyanide, and then it will be thickened and sent into the tailings facility. I purposely left out number 5 and number 6, as this will be the expansion scenario. On the expansion scenario, after the ball mill, it's going to be a float operation, a bulk float operation, which will then be reground and sent back into the leaching circuit and back into a CCD. So number 5 and number 6 right here in the flow sheets, those are the expansion scenario starting from year 4. And we'll see why we decided to do the expansion that way. In the following slides. Okay. First of all, here's the here's a summary of the design criteria. On phase 1, we're going to be processing around 3,000 tons per day of ore, and when we go into phase 2, this is going to increase to 4,000 tons per day. Life of mine will be around 11 years for the processing plant, and 13 years for 13 years mining, and the process plant will be operating for 11 years. There will be a slight dip in grades on phase 2, but the recovery from the float con leach will be increased. As we saw on a previous slide by Karl, the ounce of silver produced will be roughly flat on the later years. And we have some more characteristics that were done were determined by metallurgical testing from 2021 to 2023. There was a metallurgical testing campaign which gave us these numbers. Okay. Okay, so the first stage of design, I'm going to be skipping the comminution for the moment, but for the first stage of the design, we're going to focus on if we were going to process this ore through a bulk flotation circuit or through a sequential float sequestration circuit. The bulk flotation circuit means that we just float everything that has sulfides in it and have a bulk concentrate, compared to a sequential float circuit where we separate the zinc values and the lead values and the silver values that go with the lead. So what we found out through a series of trade-offs on this is that if we went with a sequential float process, we would be losing revenue on the zinc concentrate. The payability of the silver in the zinc concentrate, it's around 70% compared to 98% if you select in the rest. So doing a sequential float circuit actually resulted in losses in spite of having the sellable zinc concentrate. And also on the later years, it was going to be pretty hard to get a sellable zinc concentrate on the Tajitos and the Copala deposits. Here, bulk flotation, what would resulted in the best NPV results, best financials. Sorry. So now that we have the bulk circuit, the metallurgical testing showed that the ore was amenable to both leaching and flotation. So, okay, do we produce concentrate or do we leach it? So there was another trade-off to see if how the economics work on whole or leach, since they provided some very similar recoveries. What we can see right here is that the Copala deposit and the Tajitos deposit do not respond so well to flotation and respond better to whole or leach. But the Napoleon deposit responds better, responds just a bit better to flotation instead of leaching. So on the mine development side, the first stage, we're going to mine the Copala and the Copala deposit first, and then we're going to start with the Napoleon deposit. So having a whole or leach first on the first stage, and then going with a float and then leach circuit on the later stage provides better economics than just going whole or leach or the flotation route. And also, if we have the concentrate leach, it also provides a more energy efficient way of sorry, forgot to mention that the diagnostic leach on the Napoleon deposit shows that we can get around 5 and 7% recovery increase if we have regrind instead of having a 70 micron grind size, and we reduce it to 20 micron, we have a 5 to 7% increase in recovery. So this is why float leaching circuit was selected for the second phase of the project instead of just going a whole or leach the whole way. So now with the comminution circuit, now that we have the silver recovery in place, we can now run scenarios on how much do we need to grind the ore. There was also some trade-off studies conducted, and we have the whole ore leach sample, and we tried 3 scenarios. We have a recovery model for 3 scenarios. One at 70 microns, one at 100 microns, and one at 140 microns. And each of these scenarios, we ran an economic model to see which provided the lowest cost and lowest capex and opex for reducing to the optimum grind size. So the scenarios were 3-stage crushing, conventional 3-stage crushing, 2-stage crushing followed by SAG mill and then ball mill, going directly SAG mill and then ball mill, or going with a single-stage SAG. Single-stage SAG, that we probably cannot get to 70 microns with a single-stage SAG, but okay. At the end, we observed that the losses in recovery going coarser than 70 microns resulted in the loss of NPV. So 70 microns, it's the optimum size for this process. As you can see right here, first there's the Copala deposit early on the first years of development, and then the Napoleon deposit starts being the predominant deposit. As we saw on the previous slides, the Napoleon deposit responds pretty well to flotation, so it makes sense to have a flotation expansion at year 4 to process this Copala, the Napoleon deposit, and have some higher recoveries on this. It also reduces the capex by having less equipment and a cheaper process, less capex intensive process using whole ore leach. And also, we now have both leaching and flotation on our flow sheets. So the permitting that was filed late February, it includes both of these scenarios. So we do not need to permit again to have a flotation plant or have a leaching plant. We have both of them applied on the permits, so that's also a plus and one of the decisions that were undertaken to do that. Okay, other decisions that were taken into consideration for this project was there's a pre-leach thickener right here. Having a pre-leach thickener coming up from the ball mill allows us to have higher percent solids going into a leaching circuit. So that reduces the size of the tank, size of the pumps, and size of the agitators. It also provides water recovery right here that goes into closed circuit with the grinding circuit, and prevents having excess solution going into a Merrill-Crowe plant. So it also reduces the size of the Merrill-Crowe plant. Another design consideration that was undertaken, it's to have a regrind mill after flotation. This saves in energy instead of having all the ore. Instead of having all the ore going through a regrind and having energy-intensive process, we only have the concentrate going into the regrind circuit right here, and we get that 5 to 7% increase in recovery for the Napoleon deposit when the expansion comes around. And the signature plots for the regrind, they're going to be underway on the feasibility study. But having a stirred mill technology instead of conventional ball mill, it helps reduce footprint, and it saves around 60%. It saves around 40% energy compared to a conventional ball mill to get to 20 microns. Another design consideration is having a thickener right here for the concentrate recycle. This concentrate recycle right here, we have 96 hours leach time. So when we go from when we expand to 4,000 tons per day, this leach time would have been reduced. But since we are now adding intensive leaching right here, we maintain the 96-hour leach time between these tanks right here and these ones right here, and we do not increase the size of these ones because we are thickening back the solution back into the whole ore leach system, but also we are recovering high-grade solution right here that goes right into the Merrill Crowe plant. It increases the tenor of the solution. And we have the CCD thickeners. The objective of the CCD thickeners at this stage was to have losses below 0.5 ppms of gold silver. We made a series mass balances and trade-offs, and right now it stands that we need 5 CCD thickeners to go below 0.5 ppms of losses. If we add a 6th CCD, we'll get diminishing returns, and it's not payable. And if we go with 4 CCDs, we have a lot of losses, of gold silver losses. So right now the number stands at 5 CCDs to have the better economics for the project. And at the end of the process, we have a tailings thickener. This tailing thickener will, well, first of all, detox does not work very well with a high percent solids. So you need around 45% solids right here. But if after detox, we're going to thicken the slurry into up to 65% solids and reduce the volume that's going to be pumped into the tailings dam. So that reduces pumping sizes and piping sizes and saves money on the saves money up front. But also, most importantly, we have water recovery right here, reagent recovery that can be recycled into the detox, and will provide a raw water consumption of around 500,000 cubic meters per year on water. And I'll go through this real quick because Karl already mentioned the tailings dam. The route goes right here, it goes under a road, and it goes back into the tailings dam. There will be return pipes. This is a low point, so The tailings dam is just a bit higher than the plant, so there will be tailings will be pumped into the tailings dam, and the return stream will be mostly by gravity. But since we have a low point right here, any spills will report into a safe contention that mitigates any spillages. And just as an overview of what we just saw, the Panuco project, well, it's in the Sinaloa district, and it has been fast-tracked for development. Will provide a base production averaging 15 million ounces of silver equivalent. Our recent MRI is going to prolong the life of mine, and right now a feasibility study is underway to increase those resources and transferring reserves. Right now, recovery is grind size sensitive, especially for the Napoleon deposit. So having that regrind stage, it's very important to keep the energy costs low and also increase recovery. And the startup will be with Copala, and then we'll provide a pathway to going into Napoleon and the other deposits for production.